Alright, I think we all agree that in these recent years, AI has taken the world by storm, right? I mean, tools like ChatGPT and different products by OpenAI are being used in different industries, right? And they're actually making our work very easier, providing us insights. They're making the entire work process a lot more faster, therefore boosting our productivity as well. Now, according to the State of the AI report by McKinsey, AI adoption has increased around 60% in the last year alone. I mean, that's a huge number, right? And businesses are continuously using AI to improve their processes and stay ahead in terms of innovation. Now, this particular point really got me thinking, because AI has this kind of significance and this impact in all of these industries. Why don't we use AI with Kubernetes? Kubernetes is one of the most widely adopted open source container orchestration platform out there. If you don't know about Kubernetes, I mean, if you've been following the channel for a while, you would definitely know what Kubernetes is. But if you don't, there's an entire workshop on Kubernetes 101 that teaches you the basic to advanced concepts about Kubernetes. You can check out the description box down below for its link. The point is that Kubernetes is one of the largest open source projects out there, but we all agree that when Kubernetes environments grow larger, it really becomes a challenge when it comes to debugging and troubleshooting any issues. Overall, it becomes really difficult to manage. So I think AI can make a big difference here, right? By adding AI to our normal Kubernetes workflow, we can make the management process much faster and much efficient. AI can help us quickly diagnose and resolve any issues that we have. It can automate any routine tasks that we have in our Kubernetes environment, and overall can improve the decision-making process of different companies, right? Now, we have already seen in the cloud native ecosystem that a lot of products have started adopting AI in some or the other way, but there is one tool out there which was released very recently, and I believe that this particular tool brings the capabilities of AI to the next level. Hey everyone, my name is Kunal, and in this particular video, we are going to learn about K8sGPT, which is a really powerful tool that brings the capabilities of AI to Kubernetes troubleshooting and debugging, and makes it really easy for you to solve any problems in your Kubernetes cluster. If this sounds interesting to you, hit that like button and let's get started. Now, before we move ahead and install K8sGPT onto our system, there are a few things that you need to configure. Number one is you need to have a Kubernetes cluster up and running. So I already have gone ahead and created one using Minikube. So if I write k get nodes, I have a single node Kubernetes cluster running. You can use any of the Kubernetes distributions out there, kind, K3D, K3s, or any other of your choice, but you need one Kubernetes cluster. The next thing we would need is Helm. So we'll actually be installing a few Helm charts while we go through this particular tutorial. So you would definitely need Helm pre-installed. You can go ahead to the Helm's website and you can go ahead and install Helm from their documentation. So once we have these two configured and installed, right, let us install K8sGPT now. So let's head over to the documentation, which is docs.k8sgpt.ai. I'll put the link in the description box down below so you all can check it out. But the important thing to understand here is that there are two ways in which you can install K8sGPT and use it with your Kubernetes cluster. Number one is using the CLI, right? And that is the most simplest and the most basic way you can use K8sGPT. The next is using the K8sGPT Operator, which we'll install in our Kubernetes cluster, and it will constantly keep monitoring our clusters for any changes, right? Now, as for the operator, how to install it, how to use it, we have a completely different section for that. But let's start with the most basic, which is the CLI, right? So to install the CLI, you can go ahead and check out the installation guide. If you have a Mac, you can install using Brew. I've already gone ahead and done that. So if I write K8sGPT version, so you can see I have the latest 0.3.9, which is latest as I'm recording this particular video. And if you do K8sGPT, you can see that these are all the bunch of commands that are available to us. We'll actually be exploring quite a bunch of these commands today, so it's going to be an exciting ride. Alright, so I hope you have already gone ahead and installed K8sGPT onto your system. The next thing we would want to do is authenticate K8sGPT to an AI backend. Okay, so if we head over to the reference, I'll show you what I mean. Head over to the providers. So in simple terms, a backend or a provider is a way for K8sGPT to talk to the large language model or the AI model that we'll be using, right? So we need to authenticate and choose one of the models that we want to use. Right now, as of recording this video, K8sGPT supports 11 backends, right? So we have all the famous ones like OpenAI, we have Azure OpenAI, we have Amazon, Google Gemini is also there. You can go ahead and use the OpenAI provider. For that, you would need the OpenAI API key, right? But let us say you're just testing, right? Like me. So you don't want to spend money on any API keys. So we'll use Ollama to keep things simple. Now, if you don't know about Ollama is basically a tool that can help you to run these large language models on your local system free of cost, right? So if you just see the list of models that are supported, so you can see these are the list of all the models that you can run using Ollama. So we have the very latest Llama 3.1. At the time of recording this particular video, you can say it was updated 7 days ago. We have all these particular models that we can use. All of them are open source large language models. We can use any of them right now. Cool. So all in all, Ollama is a pretty great way for you to run large language models if you don't want to spend any money. So that's what we are going to use K8sGPT with right now. So you can go ahead and download Ollama for a particular operating system. There are a bunch of different options for Linux, Mac, and Windows. I've already gone ahead and done that. So if I write Ollama, so you can see the Ollama CLI is already up and running. Okay, once you have installed Ollama, right, let us see how we can authenticate K8sGPT with the AI backend, right? So for that, we have a command called as K8sGPT Auth. Let us write this. So K8sGPT Auth provides the necessary credentials to authenticate with the chosen backend. Now there are actually a bunch of options we can use here. So if I write K8sGPT Auth list, this actually gives a list of all the supported AI backends, right? So you can see that we have a lot of them right here. And the default one is OpenAI, and we also have Ollama, one of them listed here. So we want to use Ollama. So let us authenticate K8sGPT with Ollama. For that, we'll use K8sGPT auth add, and we can see it has already given us the command. So I'll auto complete it. Let me just walk you through it quickly. The number one flag we are providing is the backend. We are selecting the backends from the list of backends that I just showed you. We want Ollama. The particular model that we want to use right now, we want to use Llama 3, which is second to the latest one right now. The latest one is Llama 3.1. We can use that as well, but let's just stick to Llama 3 right now. And this is the base URL, right? So the base URL is basically the API endpoint where your large language model is running. Now this basically depends on the AI provider that you're using. On some of the AI providers that are listed out here, you wouldn't need to use this base URL. Now why we are using this base URL is because we are running this locally. So this is basically at localhost. If you are using a provider such as Google Gemini or OpenAI, you would not need to provide this. You would just need to provide the authentication key, that is the API key, right? But right now, as we are running this locally, we would need to provide it as the base URL. That's how K8sGPT will be able to contact the Ollama API. So let us hit enter. It will say Ollama is added to the AI backend. Now, if we just do K8sGPT auth list, you would see that Ollama is an active AI provider right now. So now whenever we use K8sGPT, right, to analyze our Kubernetes cluster, in the backend, it's using the Llama 3 model. And how is it doing it? It's using Ollama as the backend provider. There's one last thing that is left to do, which is starting the Ollama server. That is also important, right? So we just have to write Ollama serve, and this will basically start the local server of Ollama. And you can see that it's listening on localhost and the port number, which we have actually configured in K8sGPT, right? So on this particular terminal, you'll actually see the request that K8sGPT makes with the Ollama backend, and we'll definitely have a look into it as well. Okay, so as I mentioned previously, right, the main purpose of K8sGPT is it uses the power of AI to scan our Kubernetes cluster, and it helps us to troubleshoot and debug any errors, right? So before we move on to testing it, let us create one error explicitly. So I have this example pod manifest here, which is named by the name hungry pod, and you'll definitely understand in a bit why we have named this the hungry pod, right? So this is a simple pod that will use the busybox container image, and we have given the CPU value as 1000. This is a pretty simple pod. Now, if we look at this right now, it doesn't look like it will create an error, right? But let us apply this into our cluster and see what happens. So we'll do kubectl. I can just do simple k apply -f, and we do broken pod.yaml, right? So the hungry pod has been created and it's in the default namespace. So if I do k get po, by the way, k is short of kubectl. I have created an alias for this. It actually becomes a little bit simple when you just use k, right? So you can see that the hungry pod is created, but it's in the pending state. Now, if you're familiar with the basic concept of Kubernetes, right? If you know your way around a Kubernetes cluster, your default approach would be, okay, the pod is in the pending state. We can use the kubectl describe command, and we can use hungry pod, right? And we can just check the pod events and see what's the problem. But let's switch this game, right? And see how far we can go with AI. So instead of using the kubectl command, we use K8sGPT Analyze, right? And let us see what it gives us. So K8sGPT Analyze is a command that will list down all the errors in your Kubernetes cluster right now. We're actually not concerned with these default resources because these were created by Minikube. We are concerned with our pod, right, in the default namespace, which is the Hungry pod. So the error is that 0 of 1 nodes are available, insufficient CPU. Okay, so seeing this, I can understand that there are no nodes available with the sufficient CPU to accommodate or to schedule that particular pod. Okay, cool. I understand the error, but Kunal, I mean, this is something that we can also do with kubectl describe, right? If we do kubectl describe PO and we do hungry pod, you can see that the events also gives the same error, right? So what's the difference? Here's when things get interesting. Let us use K8sGPT Analyze again. Now that we know the error, right, we can use the explain flag to list down the solution for that particular error. Let me show you how. We just write K8sGPT Analyze explain, and -b is the flag that we use to specify the backend. So right now we are using Olama, right? And we just do that. So now is when it will contact the backend API, right? And you can see here that something is happening in the Olama server because K8sGPT is actually trying to contact the API, and you can see that multiple post requests have been sent to this particular address. It is localhost API/generate, and this is what K8sGPT is doing in the backend, right? Let us see the results now. Now it has actually given us a bunch of things which are helpful. The number one is it has simplified the error message. So it says insufficient CPU resources available to schedule the pods, with one node having insufficient CPU and no preemption victims found. Basically the error that we got, but it has simplified it and basically presented it in plain English, right? And it's much easier to understand now. And the interesting part is it has given us all the possible solutions that we can use to fix this particular error, right? So the number one is you can check the CPU utilization of that particular node. You can scale down or delete the less critical pods to free up the resources, and there are a bunch of things that you can try out. Now this is pretty interesting, right? Because let us say you are a beginner, right, and you don't know your way around Kubernetes cluster that much. This is pretty helpful for you because this just gives you a head start, right? And you can see what are the different solutions that I can use to solve this particular error, and this also helps in your learnings as well, right? So before solving it, right, let us see what is the CPU capacity of our node, right, which caused the error in the first place. So if I do kubectl get nodes, if I do kubectl describe nodes minikube, so in this particular section, if we scroll up a bit, we'll see a section named which is capacity right here, and you can see the CPU limit is 11 cores, right? And if you remember our pod, we have given it 1000 core CPU, right? So that's what was causing the error in the first place, right? And now if you look at the solutions, see the fifth one, adjust the pod's resources request and limits to better match available node resources. So the available node resources is 11 CPU. There's a cap there, right? So let us say we change this to 5 so that our node can accommodate this particular pod. So in order to apply these changes, we'd have to delete our pod first, right? So I can do so let us do k get pods, then we'll do kubectl delete pods, we'll do hungry pod, and we'll also use the force flag. This is optional, by the way. So now the pod has been deleted. Let's reapply the pod now. So we do kubectl -f broken pod. The pod has been applied, and if we do kubectl get pods, it's in the container creating state. We do again, yep, the pod is running successfully. So we have fixed that particular error. Now if we do K8sGPT Analyze, right, without the explain flag, if you remember, K8sGPT Analyze gives you all the errors in your particular cluster, and now if we have fixed that particular error, it shouldn't give us again. So if we do analyze right now, see there are only 4 errors, and the error it was showing with our pod has gone from here. Okay, so I hope you understood a very basic example of how this works. Let us try one more example which will give you a lot more clarity, right? So let us create 2 more resources. Number one is we are creating a service, right, which is by the name pod svc, and I am also creating a pod which is the nginx pod, and we are attaching the pod with the service using these labels, right? So let us apply them. We'll use kubectl apply -f, and what was the name? It was pod svc. Yep, let us apply them. So you can see the service has been created and the pod has also been created. So if we do kubectl get service, so I can see the service is right here. And if we do kubectl get pods, the nginx pod is currently creating the container. Okay, so the pod is already created. But interestingly, you'll notice that there are no errors, right? I mean, just having a look at it, you cannot see any errors. Everything is running perfectly. But we all agree that looks can be a little bit deceiving, right? So let us use K8sGPT analyze to see if we have any hidden errors that might have occurred. So let us see. Okay, so if we just scroll down to the list, you can see that there is an error with the service. So it says that service has no endpoint, expected label app nginx. So there is some kind of error with the service and it has to do something with the labels, right? I'm not going to check how you can solve it because that's where K8sGPT would come into the picture. We can use K8sGPT. Again, we'll use the same command, K8sGPT explain -b olama. So it has given us a bunch of solutions. Let us scroll up. Okay, so it says the service has no endpoints, expected label app nginx. Let us see what are the solutions. It's saying check if the service is created successfully. It is. To my knowledge, we have just checked it right now. Verify that the pods are running and have the correct label app nginx. Okay, ensure that the service is referencing the correct port in the spec. Try deleting and recreating the service and updating the pods labels to match the expected label. Okay, cool. So let us see the second one, right? It's saying verify the pods are running and have the correct labels app nginx. Okay, so let us check what are the labels being used in the service, right? I'll do service o wide, and here you can see that the label is app nginx, right? And what is something we are using in the pod? Okay, here we are using nginx, and here you can see there is a spelling mistake. It's saying nginx without the I, right? Let us say you copied any manifest blindly from the internet and it got applied and there are no errors to be seen, but at the end of the day the service won't work, right? Because the labels are incorrect, and this was something that you couldn't see with your eyes, right? Because everything was working fine, but K8sGPT was able to recognize this error. Cool. So now we know what the error is. We can quickly fix it. We can do kubectl label pod, and it has already given us the command, so it's nginx pod. We'll change the label app to match it with the service, and we'll also use the override flag which will override the existing labels. So the pod has been correctly labeled. We can just verify it. We can do kubectl describe pods nginx pod, right? And if we just scroll up and verify the label from here, it is app nginx, and I think this was the one that the service was also using, right? App nginx. Cool. So now the labels have been matched, right? Now if we run K8sGPT analyze, it shouldn't give us any error with our service or either our pod. See, the error is gone. So this is how you can use K8sGPT CLI, right? This is a very basic use case of using the CLI, right? You can quickly check for errors. You can quickly debug these errors and troubleshoot them. Now the examples I showed you are pretty simple, you would say, if you have prior knowledge of Kubernetes, but imagine any complex example. So I think K8sGPT in that particular case would be a very handy tool to first locate that particular error and then give you potential solutions that you can use to solve it as well, right? Now before we move on, one thing I would definitely want to point out is that when we use K8sGPT analyze with the explain flag, the accuracy of these solutions it provides us, right? It depends on the AI model that you're using. It depends on the LLM that you're using. So if you are using any advanced model with K8sGPT, for example, OpenAI, because it has got GPT-4, the most advanced model out there, right? These results would be more accurate. So all in all, the bottom line is that the more accurate large language models you will use, the more accurate you'll get the results, right, of your particular issues. This is something that I wanted to mention here, but right now we are testing it locally and Olama is working perfectly for us, to be honest. But yeah, this is the reason that OpenAI is the first backend that K8sGPT supported, and it's the recommended way for you to use K8sGPT. So one thing you might have noticed when we use the K8sGPT analyze command is it scans the entire cluster and it was actually giving us all of the errors present, right? So if we do K8sGPT analyze, so you can see that it is giving us all the errors with all the different components that we have. Now, because this is a demo scenario and we are just learning how to use this particular tool, that's completely fine. But imagine if you have thousands of Kubernetes pods running, right? And in that, you would definitely need to focus and filter out particular resources. For example, you just want to filter out all the pods and just run the scan on those particular pods. Or you might have some services, or you might have deployments, and you just want to run scans on those particular deployments, right? Let's say you just want to focus on a particular namespace. For example, right now, this particular scan is not namespace scoped, right? It is giving me all the results from the kube system namespace. It also gave us result from the default namespace when we ran it previously. So we want to filter out resources and we want to filter out namespace as well, right? Interestingly, K8sGPT supports this. So it provides us with filters. So filters are actually a way for selecting which resource you wish to be a part of the default analysis, right? So if we just do K8sGPT filters, so the filters command allows you to manage filters that are used to analyze Kubernetes resources. You can list the available filters to analyze resources, right? So again, this is a way for you to filter out different Kubernetes resources which you want to be a part of the scan, and you can just keep the results clean and only focus on what is needed at that particular time, right? So if we do K8sGPT filters list, so this basically gives you a list of all the available filters that you can use, right? So we have deployment, pod, service. These basically include all the main Kubernetes resources, right? And we can use this resource names as a filter with the default scan, right? Let me show you how we can do it. Okay, so to test it out, I'll quickly create a bunch of errors. So I'll quickly apply some malicious pods here. One is broken pod, which is hungry pod. That's a pretty funny name. You would definitely agree with me, I hope. And then we'll also apply the service and the pod as well. So now if we do kubectl get pods, you can see that we have the hungry pod, which is again in the pending state because I already changed the CPU limit to 1000 again because we want K8sGPT to detect the error, right? And then we have the nginx pod, which is already running, and we'll also have the service, which is already running, right? So again, if you remember, the label is not correct, right? In the pod it is nginx, and in the service it is nginx without the I, right? So K8sGPT will actually catch this particular error, right? Now if we do K8sGPT analyze, so you can see that it has caught the error in the service and also the pod. But let us say we want to filter out only the pods, right? So what we can do is we can first see the list of filters which are available, right? So let's filter out all the pods, and that's what we want K8sGPT to analyze, right? So we'll do K8sGPT analyze, do analyze, and then we'll use the filter flag, and then we'll write the name of that particular filter. Cool. So you can see that it has filtered out all the different errors that we were getting in our cluster, right? And now we are only just focused with our particular pod, right? Now if we want to provide again any solution, we can just write the explain flag, and we'll just use -b olama, and will only give us the solution for all the pods. Let us say you want to change the filter to service. We can do that. We can just type service here, and it will filter out all the services that you have running in your cluster. I only have one, so that's why it's giving me one. But let us say you have multiple services running, so it will scan all these services and only output the names of the service which may have some error in them, and that's what it's doing right now. So the filters makes it pretty interesting, right? Now there is one more interesting flag that I would definitely want to mention, is the namespace flag, which you can use to restrict your scan to a particular namespace. Let us say you have a malicious pod running in different namespace, right? Because by default K8sGPT would analyze the default namespace, right? So let us say we create a new namespace, create namespace, and we'll write demo. We can, check as well. So the demo namespace has been created, right? Now we can create the pod in the demo namespace, and we write -n demo. So if you do k get po -n demo, so you can see the pod has been created in the demo namespace, and this is again the hungry pod, right? It has got some error. So if we just use the K8sGPT analyze command with the filter, right, with the pod filter, so this will list down the pod which is running in the default namespace and the one which is also running in the demo namespace. But I only want to restrict it to the demo namespace, right? So what I can do is I can type the namespace flag, and I can only just give it the name of the namespace. So it has filtered out and given me only the pod which is running in the demo namespace, right? Let us say we try to filter out service, right? So we don't have any service which is running in the demo namespace. So it will give us no problems detected, because number one, we don't have any service which is running in the demo namespace. And number two, even if there was any service which was running, if the service does not have any errors, it will not show the errors here. So if K8sGPT is not able to find any errors in your cluster, it will give you this particular results, no problem detected. That means your cluster is fully secure and there are no errors for you to solve. Cool. Something you can also try is you can use multiple filters. So let us say if I quickly see the filters list. So let us say I want to use the pod service and I also want to use the node filter, right, in one single command. So you don't have to write it separately. You can just separate them by a comma and you can just write filter and you can also write node. So it will only give you the pods service or the namespace which has some error. Right now we can see that the node doesn't have any errors, so K8sGPT won't show us, but we can see that we have errors in pod and service, and that's what K8sGPT has given us, right? And we can also make it namespace scoped, so we can just write default namespace and will not give us the pod which is in the demo namespace, right? Now there are a bunch of other interesting flags that you can try out with the analyze command. The namespace flag we already looked into. There is another flag which is the output. You can change the format of the output you want, right? If we can just do K8sGPT analyze -- explain and we use Olama and run, we'll write output JSON. So it will give us the result in a JSON format like this, right? So this particular output is pretty useful if you're looking to integrate K8sGPT with any other tool, or if you're looking to automate any task by integrating K8sGPT, right? So JSON format is something which is followed and parsed in a lot of different tools out there, right? So this particular output format can definitely help you in that case. Another one that I would definitely want to mention is anonymize. Now, as I mentioned previously, when we are using K8sGPT, the user will send the command to the K8sGPT CLI, and the K8sGPT CLI will send all the information of that particular command and your system to the AI provider, and that's how AI provider will then process it, return it back to the CLI, and then we'll get the result and it will return back to the user. Now, let us say you are concerned with the security of your system, right? You may not want to send potentially sensitive data to OpenAI or any other AI backend, right? I mean, you don't want to send that. You don't want to do it. So there is a flag which you can use, which is called as anonymize. So we can just use this flag with the analyze command, and I'll also put the JSON output so I can explain it in a better way to you. Now what actually happens in the backend when you use the anonymize flag, now when we send request to K8sGPT, it will retrieve all the information, right? And additionally, it will mask out or hide all the sensitive information. That could be names of Kubernetes resources, labels, or that could be Kubernetes secret as well, right? So K8sGPT will mask all this information before sending it to the AI backend. Now the AI backend will normally process this information. It will return it to the K8sGPT CLI. It will again unmask all the hidden values and it will replace it with the original name of the Kubernetes resources, and that's what the user sees in front of us. So at the backend, K8sGPT is actually hiding all this kind of sensitive data, right, before sending it to the AI, and you don't have to worry about any sensitive data getting compromised in your cluster, right? So if we just see the output here with the anonymized flag, here you can see that because we had some kind of labels with our service, right? So it has created a separate section which is called as sensitive, and this is the unmasked version and this is the masked version. So the masked version of this particular label or the hidden version is what K8sGPT is sending to the AI provider, right? You can scroll down and see more such examples, right? So we have the Kube API server as well. This is also masked. So this is the value that is being sent to the AI backend by K8sGPT. And for example, if we just use the anonymized filter and we don't use the output flag, you can see that we are able to see all the original names, right? And that's what K8sGPT actually does in between. It replaces all the masked value with the actual names of the Kubernetes resources. Cool. So I think we have covered a lot of important flags and some additional functionalities you can use with the analyze command. If you want to check out more, you can just type K8sGPT analyze help. You can check out more interesting options that you can use. You can also change the language of the output, right? So K8sGPT supports a bunch of language as well. This is pretty interesting, but I hope that by now you would definitely have a lot of clarity on how K8sGPT actually is working, right? And what are the different flags and what are the different options you can use with the analyze command and how you can customize your scan to fit your particular use case. Okay, so let us talk about integrations, right? And how you can integrate K8sGPT with other tools in the ecosystem. And I think when we are talking about the cloud native ecosystem, right, the main value lies in how well a particular tool can integrate with the other tools that are involved in the CNCF landscape. And K8sGPT actually provides us a very simple way to integrate with a bunch of tools. So let us take a look how we can work with integrations in K8sGPT. So for that, we have a pretty simple command called as K8sGPT Integrations. And here are a bunch of options that we can use. We can activate, deactivate, and list the built-in integrations. So let us first list the available integrations right now. So we can do K8sGPT integration list. And these are all the available integrations at the time of recording this particular video and in K8sGPT version 0.3.39, right? So we have Trivy, Prometheus, AWS, KEDA, and we have Kyverno, which is the very latest one. So how you can install these integrations and how you can use them, you can find it in this particular documentation right here. Link is in the description. But in this particular video, we are going to see how we can use the Trivy plus the Kyverno integration as well. Okay, so let us start with Trivy. Trivy is basically a vulnerability scanning open source tool by Echo Security, and it helps us find any vulnerabilities, misconfigurations, SBOMs in containers and all that stuff, right? So it can basically scan container images, file system, Git repositories, virtual machine images, Kubernetes, any resources on AWS and all that stuff, and it will list down all the potential vulnerabilities of that particular resource, right? It's a pretty interesting tool, and if this is your first time, make sure to check it out. I'll leave the link in the description box. So in order to use Trivy, we just need to activate that integration. So we can just use K8sGPT integration activate Trivy. And what this will do is it will install the Trivy operator itself onto our Kubernetes cluster. So as you can see, most of the resources for me were already present, so it has skipped everything. But essentially at the end, it says that the Trivy operator K8sGPT is installed. We can also actually check this using Helm. So if we do Helm list, you can see that the Trivy operator K8sGPT is deployed right now. Cool. Now, if you remember, in the previous section, we discussed about filters, right? And filters are a way for you to customize your scan based on certain resources. Now, any particular integration you add with K8sGPT, right, it will add more resources to the list of filters, which we can use with the basic command, right? Now, if we just confirm whether the integration has been added or not, we can just write K8sGPT integration list, and you can see that the Trivy integration is active right now. Cool. Now, if you just write K8sGPT filters list, you can see that two more resources have been added here. Number one is config audit report, and the number two is vulnerability report. These were the part of the Trivy integration, right? And now we can use these particular resources as a filter with the K8sGPT analyze command. Cool. So let me show you how it works. Let's see if we have already a bunch of resources running. Yep, we already do. Okay, first let's copy the name from the filters list. Let's say we want to use the vulnerability report filter. Cool. So we can write K8sGPT analyze, and we can just write filter. We'll paste the name of the vulnerability report filter and we'll use it. So now if you see, we used K8sGPT analyze, which gives us all the errors in our particular cluster, right? But we used the filter as vulnerability report. This is pretty interesting, right? Because at first we are able to use K8sGPT to analyze all of our errors in the cluster, and then we use Trivy to get the vulnerability report of all the errors, right? Now, if you have used Trivy before, you would know that it categorizes all the vulnerabilities into three categories, which is normal, medium, and critical. So by default, K8sGPT will only display the critical vulnerabilities found. And another thing which is interesting is you can head over to one of these links and you can learn more about this particular vulnerability as well. So I think this is pretty cool, right? And again, we can use the explain flag. So we'll just wait for a couple of seconds to do its thing. Okay, this definitely took some time, but now it has provided us with a lot more information about that particular vulnerability as well. So you can see it has given us the information about the vulnerability, what exactly it is all about, what's the root cause, what are the potential risks, and what are the potential solutions we can use to mitigate this vulnerability, right? So this is pretty cool. And similarly, you can also use the config audit report with your K8sGPT analyze command, and that's how you can filter out the resources accordingly. So that's pretty interesting. Okay, so let us see how Kyverno integration also looks like, right? Because that is the latest integration which came with the 0.3.39 version. You can also find the pull request here as well, and you can check out how it was made. because this is the very initial stages for this particular integration. Now, if you remember that when we use the Trivy integration, it automatically installed the Trivy Kubernetes operator onto our cluster, right? But for some advanced integrations, for example, Prometheus, you would need to have the Prometheus operator previously configured and installed on your cluster, right? Before you can activate the integration and use it with K8sGPT. So that is the same case with Kyverno. So before we use the Kyverno integration, we would need to install the Kyverno operator in our cluster, and we would need to set that up before we can use it with K8sGPT. Cool. By the way, if you're not familiar with Kyverno, it is a policy engine that you can use with Kubernetes to validate your resources, right? I'll leave the link in the description box. If this is your first time hearing about it, you can check out the documentation as well. But let us install the Kyverno operator first onto our cluster. So for that, we have these 3 commands that we'll run. Number 1 is we'll add the Helm repo of Kyverno, then we'll do a repo update, and then we'll install the Kyverno operator in the Kyverno namespace. We are also creating a new namespace. So we'll do a bunch of things. I already have the Kyverno chart, so it detected that, and it has deployed Kyverno in our cluster. So if we do kubectl get ns, so you can see a new namespace has been created. And if we do kubectl get all -n Kyverno, you can see these are the bunch of resources that Kyverno has created for us, right? So we have a bunch of deployments, we have a bunch of pods which are running, services which are running. We don't need to worry about it right now. You can check out in the description for more resources. But the essential thing is that the Kyverno operator installed, and now we can integrate it with K8sGPT. So we can just do K8sGPT integrations list, and then we can add the Kyverno integration. We can do K8sGPT integration activate Kyverno. You can see that it has added Kyverno to the active list, right? And now if we do K8sGPT filters list, you can see we have 2 resources that we can use as filters with the analyze command. One is the cluster policy report and one is the policy report. Now before we move on, we would also need to create a validation policy, right, against which Kyverno will check for any errors. So I've already gone ahead and created one from the documentation itself, and this particular policy will check whether a pod has the label team or not. If the pod doesn't have that particular label, Kyverno would not let the pod be applied to the cluster. Cool. So let us just apply this policy. This is, by the way, directly from the documentation. You can also create your own policy if you wish to. So the policy has been applied, and we can just quickly test it. So let us say if we run an nginx pod and we don't give it the label team, right? So you can see that we received an error from the server, and it says that the label team is required. And if we add a pod with the label team, and we can use app, let's say, so the pod will get created, right? You can see the nginx 2 pod is running now. So the validation policy is also working, right? We have Kyverno operator installed. We have set up a validation policy, right? Now there are a bunch of resources which are already running in our cluster. Now we want K8sGPT to first scan our entire cluster and only find the resources which violates this particular policy, right? So what we can do is we can just write K8sGPT. Let me just find the name first, and then we can do K8sGPT analyze, and instead of the vulnerability filter, we can just use the policy report filter. And you can see that we have a whole bunch of resources in our cluster which are not following this particular validation policy. So this is how the Kyverno integration is working, right? And you can definitely use the explain flag here to find the solution as well, but we already know the solution, right? We don't have the team labels with these particular resources. But all in all, this is how the Kyverno integration looks right now. Something I would definitely want to mention is that as the Kyverno integration is at a very early stage at the time of recording this video, you may find some kind of errors, right? Sometimes it may not work when you may add additional filters to it. This is at a pretty initial stage and the community is actively working for it. So if you encounter any new problem, feel free to open an issue to the K8sGPT GitHub repo. I'll link it down in the description as well. And I think that's the benefit of it being an open source project, right? We can all help it improve. Cool. So I think we have covered a bunch of stuff. Let's see how the K8sGPT operator works now. Cool. So I think we have spent an extensive amount of time exploring the K8sGPT CLI, right? And I think this is a great way to get started and perform quick scans in your cluster. Now, what if you want to continuously scan your cluster, right? You don't want to mess with the CLI. You don't want all these manual processes. So for that, we have the K8sGPT Operator, which you can install in your Kubernetes cluster itself, and it will continuously scan for any errors and any issues in your cluster, and you can continuously view those results and resolve the issues as well. So this is basically the architecture of what are the different components that are included in the K8sGPT Operator. So you can see we have the operator, we have the Kubernetes custom resource definition, and then it creates a bunch of K8sGPT deployment which talks to the API server, and that's how it communicates with the Kubernetes operator. Optionally, you can also set Prometheus to scrape out the matrix of the particular operator, and you can monitor the performance of the operator itself as well. So installing the operator is pretty simple. We are just using Helm to add the repo, update it, and then install the operator itself in a new namespace. I've already installed it, so it's already running in my system. I'll not do this. So if I just do K8sGPT get ns, you can see that a new namespace is already created. And if I do K8sGPT get all, kubectl get all, so you can see I have a deployment, a service, and a replica set already up and running. And these are the resources that are a part of the K8sGPT operator. Cool. Now, according to the guide, now the next step which we would need to do is deploy the API key of the backend that we are using as a secret, right? So right now I'm using Ollama, so we don't have a secret to be deployed, but according to the documentation, it's given that it's compulsory. So this is what I did. If I write K8sGPT auth list, you can see now the active backend is OpenAI. So I replaced Ollama with OpenAI, right? Using the API key. You can create your account on OpenAI, or you can also write K8sGPT generate, which will automatically lead you to that particular page where you want to create your API key, right? So now that we have our API key ready, we can create this particular Kubernetes secret. And before that, I'll just export this environment variable. So we can just write export. You don't need to copy this because this won't work after the tutorial. I'll be sure to delete it. And now let's create our secret. It said failed to create secret, already exists. Oops. So if I do k get secrets, okay, I can do secrets in all namespaces. So I think it's in a different namespace. Yep, here it is. So let us maybe delete it. That's the simplest possible solution I can think of right now. So if we do k delete secrets -n, the namespace is this, and the secret we want to delete is this, and we'll use the force flag. You don't have to use it again. Cool. I think now the error should be gone. So now we can create the secret. Okay, the secret has been created. Now we can deploy the custom resource of K8sGPT, right? So before we apply, let us examine the file first, right? So it's a kind K8sGPT. The model we are using is 3.5 Turbo. The AI provider we are using is OpenAI, and the name of the secret which we have just created. The only thing we need to change here is the version. So make sure you are on the latest version. You just need to replace it with the latest version that you are on of K8sGPT. Cool. And I think everything looks good. Now we can just apply this. We'll do K8sGPT apply resource, and you can see that the resource K8sGPT sample has been created. Okay, so once you have applied that particular resource, right, you can just go ahead and do kubectl get results in the JSON format, right? And right now it's empty because this particular step takes a little bit of time. It is also mentioned in the documentation as well. Once the initial scans have been completed, after several minutes, you will be presented with the results custom resources, right? So this is how the results look like. It will give you the details, and it will also give you the error as well, right? Now, an interesting way in which you can view these particular results is via Prometheus as well. So if we go to references and we head over to the options here, so these are a bunch of options that you can set and customize how you want to use the K8sGPT operator, right? For example, as it's mentioned in the diagram as well, we can use Prometheus to scrape out the in-cluster metrics, and then we can use Grafana to view those particular metrics, right? Now this is something I'm not gonna show in this particular video because I think it has already been a long one and we have covered a bunch of interesting stuff, but I'll not leave you hanging. I'll leave a link to a resource that you can check out in the description box if you want to know how to set Prometheus and how you want to enable Grafana as well. And that's how you can use the K8sGPT operator to its full extent. Cool. I think we have covered a lot of interesting stuff. A few things that I would definitely want to mention before we part ways. If you are new to K8sGPT, you can check out the K8sGPT CLI tutorial, which is with Killer Coda, right? So this is a great way for you to just get started, get to know how the CLI is actually working. Just play around with the commands, right? And see how they are working, right? So shout out to the community for creating this. Two additional things that is something for you to explore is how you can create custom analyzers. So if you remember that when we do K8sGPT filters list, so the Kubernetes resources that you see in this particular list are actually called as analyzers, right? And if you head over to this repo of K8sGPT, you can find the analyzer.go file, and here you can see the list of all the analyzers that are built into K8sGPT, right? So one interesting thing is that you can write your own custom analyzer that matches your specific use case. So this particular guide will provide a way for you to write your own analyzer, right? It has a bunch of things, so you can definitely check this one out. Another interesting thing you can also check is how you can integrate K8sGPT operator with Slack. This is something interesting because, for example, if your team is working on Slack and you will want constant updates from K8sGPT, you can configure the operator to use Slack and it will send you constant updates about any issues that may occur, right? And it's pretty simple, it's pretty straightforward. You just have to uncomment this particular section and you just have to add the Slack web URL here. This is definitely something for you to explore, and by the way, all the steps are also mentioned in the documentation as well for your help, which you can check out and follow along. Cool. So I think we have covered a lot in this particular tutorial. I hope that you were able to follow along and learn how K8sGPT actually makes the entire process of debugging and troubleshooting a Kubernetes cluster really easy and really simple for you all. I definitely believe that this is just the start. We are already seeing a huge impact AI has been making in the DevOps and cloud native and all of the other tech industries. And I believe that K8sGPT is one such tool which really shows promise, and it really shows the impact AI can make in managing a complex Kubernetes environment. A quick summary of what all we covered in this particular video. We covered what is K8sGPT. We then went on to the installation. We saw how K8sGPT helps you to analyze your cluster for any errors. Then we also took a look at how K8sGPT connects to an AI backend provider to provide you with potential solutions in simple language. Then we also saw how we can integrate K8sGPT with different tools in the cloud native ecosystem. I think that's a really powerful feature, and the community is actively working to include more integrations into the code base. And lastly, we also had a nice overview of how we can use the K8sGPT operator and some of the additional features like Slack integration and how you can create your custom analyzers. Now these are some features I want you to try out, and let me know in the comment section down below what do you all think about it. Lastly, all the resources I showed you in this particular video and some additional resources, I'll be sure to link it down in the description box down below so you all can check it out. And the K8sGPT community is growing, so give it a try and don't hesitate to get involved in its development as well. But yeah, if you really enjoyed the video, make sure to hit the subscribe button. I think you'll find it somewhere here, and make sure to hit that like button for the algorithm. It really helps us out. But yeah, I'll see you all in another video. Bye.